So back again, and as promised in my introduction video before, the two Temu machines that I've got, the Temu Coil tattoo machines, which are total crap. It's one of them. This is the one that didn't work. Well, it broke after the first time I used it. First time I tried it, so it just stopped working. So I think that's the one we're going to strip down right now and find out if we can see exactly what was wrong with it, first of all. And then we're going to suss out what we can replace to make it, I don't know, maybe actually usable. I'm not suggesting you should go out and spend £8.50 on Temu and stuff like that, but there's no real replacement for getting a well-made, custom hand-built sort of coil tattoo machine from whoever your favourite builder is. But let's see if we can actually do something with this. Now, at this point, I will stress, I know all this has been done before. Maybe not with this exact machine, but I know people have bought, Chinese machines and done videos on reworking them. I just thought I'd do my take on it, that's all. I'm not trying to be anything innovative or anything new. It's just for a bit of fun. Okay, so let's see where we can go. Let me set the camera up down here. The workshop bench is a bit of a mess. I've put a yellow rag down. I'm going to strip this down and see what we're up against. Catch you in a sec. Right, so here we are. Here's the machine. We don't need too many things in the way of tools. Maybe some wire cutters. And let's get on with it, eh? So let's just strip it down completely and see where we're at. And take literally everything out and see what we're looking at quality wise. These are the plastic insulators. These sort of isolate the front contact post from the frame, obviously. As I said before, a little let's take this completely apart. You know what? I'm not being funny. I have actually seen worse contact screws than that. Well, So anyway, there we go. So that's that. Let's take the take all this off. Let's just take it off anyway for the sake of it. All right. There we go. Some reason I'd used a, oh no, that is a metal washer. I thought it was plastic. Not very good, whatever it is. We'll take everything out because I think I'm going to probably refinish this frame. I'm not even sure if it's magnetic. Let's let me get a magnet, and no, there we go. Look, so that's a strong magnet. That's just an aluminium frame. I did suspect it because it was quite light. So that's why they've put a yoke under the coils here. So I'll just explain this quickly. So normally, if this was a steel frame, you needed to jack the coils up a bit to meet the armature bar, then you would just put a couple of washers under here and you'd be okay. You don't need the added weight or the added hassle of this yoke because you'd be using the bottom base plate of the machine as the yoke between the coils. Now, but because this frame is aluminium, you won't get a continuous magnetic circuit. So do you remember the type of magnets that were like a U shape, if you like? Those typical sort of cartoon type magnets that you see. Well, that's what you're creating with this circuit. You want a circuit that starts there, goes all the way around and finishes there. So you've got a north and a south pole on your magnet, so to speak. And in order to complete the circuit between the two magnets, you're fitting this steel yoke. Now, this partly explains why you shouldn't use aluminium or brass washers or stainless steel washers under your coils, because they will interrupt with the magnetic continuity of the circuit. So if you imagine if you've got a non-ferrous or non-magnetic washers under here instead of this yoke, okay, or as well as this yoke. Say you wanted to jack this coil up a little bit more on top of this yoke, but you were using a stainless washer or a brass washer, it would interrupt that circuit and it wouldn't be as good. Okay, your steel bolt will still be connecting through, but it will quite seriously interfere with your circuit eventually. Okay, so I've explained that, so let's carry on. So let's see if we can get these contacts out of the way. These clip cord, these rear contact posts. I'm not bothered what happens to the screws. That doesn't matter because I'm going to put all new screws on it. That's fine. So we've undone that from the top and bottom. Now, what I will say is this is what is called a radial capacitor. Circuit goes in, spins around, comes out. It stores excess voltage. Now, they're okay, but I always use what they call axial capacitors, which are effectively these. I'm going to show you now. So this is an axial capacitor, so it goes in one end, comes out the other, not in and out the same end. And there's an indentation in that capacitor, and normally, and also an arrow. That gives you your flow. Now, the flow should be from the clip cord up to the front contact post. So it would be that, there's the indentation. I don't know if you can see that very clearly, but there's an indentation and an arrow on it. Let's see if I can show you the arrow. There's an arrow there. Okay, there is one on it. Most capacitors have it on. And you're supposed to put, in best practice would be to put the positive into the bottom part of your clip cord connection, the lower clip cord connection, and then that puts the power the correct way through the capacitor. It's marked as this being the positive side. Okay, they will run the wrong way around, and the amount of times I see machines with them the wrong way around, you wouldn't believe. You can go and have a look at any builder's photos and you'll probably see them, but from day one I knew capacitors and I knew that this is the way around they're supposed to be. So just take note of that. If you are building, make sure you put your capacitor in the right way around. It will improve the life of the capacitor. Okay, there's going to be people arguing with that, but I don't really care. I'm just telling you as it is. Right, so we'll take the coils out next. Might have to get another different Allen key actually to get the armature bar off. Doesn't matter where all these bolts go because I know where everything goes. I've built enough of these machines. Well, I've built enough machines, should I say, to know what's what. There's quite a lot of oil on that as well. Look, there's quite a lot of oil there. There's the yoke, which we would hope is that is steel. I've just tested that with a magnet. Magnet's quite strong and it's stuck to my door frame. It's easier just to, I can smell the oil on that as well. So let's have a look at these coils and see where there's a break in a wire somewhere, right? And I suspect it's probably about there. So it's not where it's going into the coils. A little bit strange, that one. Maybe it's a dry joint or something. I shall go and get a multi-tester and let's do some tests and see what readings we're getting on these. Right, so I got my tester, continuity tester. I'm not actually going to be testing. Hang on. I'm not going to be testing capacitors as such because this actually doesn't test capacitance. I do have a tester for that, but it's at work. Right now, got continuity through these coils. So let's check resistance. 9.1 ohms of resistance. And get a set of my coils. And I just want to check, compare readings, see what's going on here. .4, that's shorty. So, okay, that's not the end of the world. I mean, we know they're crappy coils. So, let's see what we can do here. So, let's put that back on continuity. So, I'm going to cut the capacitor out of the circuit completely, okay? And what we're going to do is we're going to scrap that, because that's a 50 volt, 47 microfarad. We don't need anything like that. And in fact, there's a prime example of using cheap rubbish. You know, this has had an extended bit soldered onto it there. The ones I use, you don't need to do that. So I think these are 25 volt. These are Vichy capacitors. And they are, yeah, 25 volt, 47 microfarad. And that's in all of my machines. Now, when I started using these, they were a little bit smaller than this actually. And then the new lot that came through were just slightly bigger, which initially worried me, but it turned out fine. They just upgraded or uprated the design. Okay, so got continuity there. And we've got continuity going through these coils. So there's no actual break in these wires. So that doesn't look particularly great. It is moving around. That's been pinched up just there, that bit of heat shrink. They're pretty drastic, I'm going to be honest with you. They're not good, but we're going to put them there for now. And I think we're going to use them. Let's put the old meter back down there for now. So, we're going to use these coils, and because, as I say, they've got a continuity through them, which means they are capable of working. They're not, let's just want to check something. So let's just put that on continuity again. So I just want to check that they're not, no, okay. So I'm just checking that we haven't got a leak there. So it would have pulled the armature bar down actually if it had a leak. Now what happens is, if you put your meter across here, in continuity setting this is, where it beeps. So if you go to either one of these and your coil core and you get a noise, it means that this is shorting out onto your coil core, which you do not want, because that will just heat up and it won't help the cause at all. And a bit worrying here, because I don't know if I've used, oh no, they are plastic washers, that's all right. I thought for a minute they'd used metal washers on the coils, which would have just been silly, because you'd get some of the enamel off the wire come off and then it would just short out onto that. So right, back to the frame. So what we'll do, we'll take this this bolt out here completely out. We'll take it completely out, and a lot of oil on here. So that, yeah, this finish on this is terrible. So where this is aluminium and it's got like a finish on it, I suspect that the problem was that the negative side of the feed wasn't getting into the frame and completing the circuit. It was kind of as simple as that. So I think what I'm going to do is take some, it looks like a sort of like a powder coating, to be honest with you. So I'm going to go over to the wire wheel now and take some of that off. And then I think what we'll do is just as a test, put it back together quickly, just to confirm that that was the problem. Then I think maybe at the same time, I mean, look at this spring, right? So I think I said in the other video, this front spring is ridiculously thin. And look, I mean, look how easy I'm pushing that down. It's pathetic. Anybody that cuts springs like that is just kidding themselves. Just don't. I mean, it's oh, it's not even a front spring. Look, it's one spring. I've only just realised that is one spring. All right, so that makes it even worse. In fact, I think the last person that I saw do that, oh no, I'm not even going to say who it was, because he was kind of a friend at the time. And yeah, look, one spring. That is fucking awful. Oh man. So basically, if your whole spring, if that spring snaps, you've had it, haven't you? Because you can't just replace the front spring. You've got to get a whole thing. Look how easy that's bending. Look, it's pathetic. Look at that. Oh dear me. That's not even spring metal, to be honest with you. It's barely actual spring metal. That's just normal, almost just thin mild steel. That is absolute shit. Right, so I'm gonna clean off some of the powder coating on this frame. I've got a couple of capacitors ready made anyway, so I'll fit one of those when we put it back together, and some new springs. I'll use the A bar, that's fine, there's nothing wrong with that, but we will need some springs. Right, I'm gonna go and do the frame. I'll catch up in a minute. So I've taken, right, here we are. So I've just been over to the wire wheel and I've taken the powder coating off this bit here and here where the negative runs through the frame and up onto the rear spring there, which I suspect was the problem. There was a lot of oil under that spring, and also would have been zero conductivity in this. But I thought, we've all heard of workhorse and iron horse. Well, I thought I'd engrave this one. It's shit horse. I messed the S up a bit there, so it's even more of a shit horse. Okay, so let's see what we can do. Should we get this back together? Yeah, why not? Should I do it on camera? What the heck? I think you've probably seen most bits coming in and out of a machine. So I'm going to get the bulk of it back together, and then once I get it plugged in, we'll get it going, hopefully. Catch you in a bit. Now here's something I've forgotten about in the past to mention, or I might have mentioned it on some of my earlier videos from 2 or 3 years ago, but a lot of these cheap machines, you do find with the coil cores that they're almost hollow. So get your Allen key or whatever, poke it up there, put your finger there, bring it out. That's how much. So that's basically half the coil core is drilled out, which you don't need. That means there's less metal in there, and that is less coil to work, or to have the wire wrapped around. Really, you need that core to be as solid as possible. So I literally just drill it out enough to take the bolts. I try to avoid going too deep on my personal ones. So there you have it. Just a tip for you if you're making your own coil cores, or if you're designing them for somebody else to do it on a CNC or whatever. make sure you don't drill them out too far. All right. So I've got the coils on. I just thought I'd show you quickly why I've cut the capacitor out of the circuit. Part of the reason was because it was bloody ugly. If you see on this one where they've put the capacitor there, it's just getting in the way. If you were to continue with that, that would just eventually just get gummed up and break off. Very difficult to clean. My version is a lot cleaner, as you can see. The capacitor is tucked up here in between the coils. If you can see that, it's right there. So I'll put it down there. Wire's going to come up here. You can't really see too much of the wiring. I mean, this is a little bit more messy than I would have liked, but I didn't want to desolder it to take that extra bit out. I just couldn't be bothered. I mean, I could do it at a later stage if need be, but what the heck. So I've still got the coil jacked up on one small washer, and I changed the bolts going into the coils to 12mm. Actually, I could have got 14, but I didn't have any 14mm long ones in there. I had 16s, which was just slightly too long. I just tapped out before I got them all the way in, so there wasn't quite enough thread. Because, you know, if your coils are hollow, you can fill it up with threaded bolt. That does help. Okay, so next thing is I'm going to sort out the front contact and get that back on. Then I'm going to respring it. I'll be back in a sec. Right, so that's the front contact post put in. Now you've got to remember both sides of this have got to have the plastic insulating washer so that this brass bit here does not touch the frame, and neither do either of those wires. Otherwise it will short out and the armature bar will just stick to the front coil. Now we'll put that in there like that. It's not, I mean, it's not the end of the world. It's not a bad contact screw or anything like that. But it had this bolt in here. Now, this obviously is there to lock the contact screw in place. But if you tighten that up onto that's a steel screw. If you tighten that up onto an actual copper thread, it's going to ruin the thread. So what I do with all of my machines, okay, cut a little bit of O-ring, all right, just the tiniest bit of O-ring, plonk it in there, all right, and then put your grub screw or whatever it is you got, all right, and put that in there, tighten that up, and all that, it's not metal on metal then, it's just a piece of rubber between that, and you won't kill the thread on that contact screw. It's the tip for today, that is. Every one of my machines has got that. So make sure if you do take that off, that you put a little bit of rubber back in there. And okay, let's put a set of springs on this armature bar. I don't think it's going to matter if we use shader or liner, but let's put some liner springs on it for now. They're all going to be 18 gauge, just going to be 37.5mm long front and a standard rear. So I'm going to put those on the armature bar now, and I'll be back to you in a sec. Right, here it is. So new pair of springs. Of course, all of my builds use a flat back spring with the brass adjuster there for tension. So it was, well, it wasn't new to me, but yeah, I almost forgot to put a little bit of tension in that rear spring there. So there's not a lot of tension, but it's okay. Let's see if it'll run up. Switch our power pack on. Hang on. There we go. Let's put this in here. Pretty sure it will, to be honest. There we go. So it was basically the problem was that there was no continuity through this part of the clip cord it goes into that which was going onto the coating on the frame, which then has to come up through here to the and through the spring. But of course there's more coating where the spring's sitting on a frame, and there was just no electrical conductivity, call it what you will. So that's why I scraped all the coating out, and it's absolutely fine now. It's running better with one of my capacitors as well. Does actually need a washer here just to bring that slightly over there. So I'll tell you what, let's just take that off now. Let's do that while you wait, sort of thing. So if we take this off, all right, now I'm just going to get a little washer. Very thin shim that I've got there is actually stainless steel. I do have mild steel, but they're slightly thicker than that, so I only want a stainless one for now, because it's only to bring that out a bit so that it, where it contacts the front spring, it's basically got linear alignment straight the way through. Okay, so if I put that up there, you can see the linear alignment. It's actually, I'll tell you the truth, for the money, you know, it's not too bad. Now, so the red bit, always down the bottom, if your capacitor's on the right way around. I always mark my capacitors with a red bit there just to remind people. So I'll put that in there like that, and hit the button again. Let's turn the volts up. That's on 6.8 at the moment. Oh, that's just overvolting slightly. See the there we go. That's optimum volts. That's, yeah, I see the ghost in the middle spring. Probably can't see that on camera, I'm not sure. It's pretty soft, to be fair. So that's quite a big gap as well, if you see that. So we're running 7.6 volts, 106 hertz, or CPS, which means cycles per second, 40% duty. So I mean, that's, see if we can, no, see if I try to speed it up, it's not making it run any harder, it's just running rougher. So let's look for the shadow again of the spring. Perfect about there. You can hear the change in tone as my body absorbs a bit of the voltage. There we go. I mean, it's a soft thingy shader, I suppose. But there you go. I mean, look, it's pretty consistent. And that is an absolute shoestring budget, not rebuild, rework if you like. So I changed the capacitor, put new springs on, scraped a bit of the stuff away, and engraved shit horse on the frame. So this is the shit horse number 1, okay, for 2024. And I don't think there'll be a number 2. I probably won't waste time on the other one, to be fair. I can't see the advantage of spending my time doing a full rework of it. Nothing's going to help because this frame is pretty crappy. I will put the vice clamp back in there in a minute. I don't know, what will I do with this? I'll probably give it away. Somebody probably have it. I don't know. Maybe I'll give it away to somebody as a surprise and send them it with another machine or something when they buy it, but whatever. Anyway, there you have it. I hope you, I don't know if enjoyed is the right word, but yeah, hope you enjoyed it with me. It was not too much of a waste of life, was it? It's just a bit of fun. I know it's all been done before, like I say. Anyway, look, like, share, subscribe. Please subscribe. I want to get up to 1,000. I'm not there. I'm only about halfway there at the moment. But I've got a new video coming I'm going to film tomorrow, and that is video number 4 for the Legends series. Meanwhile, I'm just going to go and make some parts for 2 builds I've got going on. I'm kind of put 2 together at the same time, so I've got to go and make the brass work for them. When you get on a lathe, it's just as easy to make 2 bits as it is 1. So I'm going to go over and make the bits for them on the lathe. I'll catch you on the next one. Meanwhile, stay safe. Catch you soon.